Today I'm going to be solving past paper questions from Pestle, which is a website that has past paper questions, and I'm using the old syllabus but mapped to the new syllabus. So right now what I'm going to be doing is A1, A2, A3, and A4. Basically, it's A1 to A4, with some topics not in A4 because we're not having that on my test. So let's go. The first topic is 2.1, motion. And I'm going to be going it through this way. So first I'm going to be doing the paper 1 So first I'll do the paper 1 SL questions, paper 2, paper 1 HL questions, paper 2 SL questions, then paper 2 HL questions. Having it the systematic way makes it easier. So for SL, then you can skip the HL parts. Alright then, the first question we have is, the graph shows a variation of, the velocity with time, velocity 0, and it's being a parabola. What this means is that there's an object, and right now it's increasing in velocity. So when I'm throwing it, it's most likely a projectile. So when I'm throwing it, and it's going over here, the velocity is increasing, and then it starts. The ball starts to speed up, and then it starts to slow down. Now, how is the distance traveled by the object shown? Well, let me explain why it's b. The reason for that is because we have displacement, displacement doesn't work here. So what's going to happen here is it's going to be like, so the ball is moving, but it's like moving, at first it's slow, and then it gets faster, okay, and then it's in the middle of the air, and then, since it's distance, and distance only increases. Distance cannot decrease. It must be this. Therefore. And it also slows down. At the end, the ball slows down, so it can't be d either, because that means it's speeding up. And that it doesn't slow down, but it's like it starts it moves a shorter distance rather than it suddenly starting to go here, and then it just drops straight down. That's not possible. It's like more like that. So it can't be C because it's going down, and it can't be A because that's linear, and that doesn't work. So it's B. Let's see if there's an examiner's report. Nope. Alright, the next question is, an object of the weight W is falling vertically at a constant speed in a fluid. So W falling constant speed means there's some form of drag, I'd imagine. What is the magnitude of drag force? Now, what is going to happen is there's a very specific word we need to pay attention to. It's a constant speed. What that means is that there's no net force on the object. That means the drag and the gravity must be equal for it to cancel out. Easy C. Alright. So, the next question is, a tennis ball is released from rest at a height h above the ground. Okay, so this is the tennis ball, and this is the height h. At each bounce, 50% of its kinetic loss. So, 50% of its kinetic energy is lost, which means it's going half of its original height. Now, what does that mean here is that after the first bounce, the height's going to be half. At the second bounce, it's going to be half of half. And half of half is a fourth. So it's h over 4, aka it's b. Alright, the next question says the variation of a displacement of an object. If displacement against time is shown, what does the area under the graph represent? Well, we'll have to realize that the change in displacement doesn't actually tell the speed, but multiplying distance into time, it doesn't really tell us anything. We know that for other graphs, like against acceleration, if it wasn't distance, but if it was velocity or acceleration, then we'd have an actual value, but it's displacement. And displacement doesn't really have a value for the area. And it's also because if you multiply displacement in time, you're going to get meters into seconds. Where the hell are you going to use this? It's in introductory physics, or we are in. That's not used at all. Next question. Alright, so alright, next, oops, let's go back there. An object is projected vertically upwards at some time 0. Alright, so it's moving upwards at time 0. Air resistance is negligible. The object passes the same point above its starting position at time 2 seconds and 8 seconds. Alright. So what it's trying to say here is that the ball is going up, and then at t0 it's going up. So at 2 seconds it's here, and then it falls back down at 8 seconds and goes back to the floor. Alright, so if gravity is 10, what is the initial speed of the object? So we're given the time, we're given the initial velocity, we're given gravity, we're given acceleration, aka, and we need to find the final velocity, and we are kind of given displacement in a roundabout way. So this is the equation we're going to use. S equals to ut minus half gt squared. This is a Suvat equation. If you plug in 10 for gravity, we're going to get S equals ut minus 5t squared. Another thing we know is that it passes the same position at different times. So what we're going to do is we're going to take this equation, S equals to something, and we're going to equate S to S8. So that's going to get us 2u minus 5 2 squared, which is 4. Oh my god, what is happening? Well, yep. 2u minus 5 4, which is 20, equals to 8u minus 5 8 squared, which is 64, which is 320. And then this is simple algebra. You'll get 6u equals 300, and that means u is 50. Well, meters per second, which is A. Alright, the next question. An object is thrown upwards. The graph shows the variation of velocity and time of the object. What is the total displacement at a time of 1.5 seconds measured from the point of release? Alright, so the next question, okay, so what we're going to do here is, how I like to think about it is, this is the graph. It goes like, goes like this, goes like this, and then it goes up back again, and then it goes like this. And then I'm not going to look at anything beyond that. This is equal to this triangle. So they cancel out. We are left with this triangle. And the top of it is 5. The base is 0.5. So what's the area? Well, we're going to multiply 5 into 0.5. This is 2.5 And then we're going to, so that's the area of the triangle. And then we're going to half it again, because the formula of a triangle is half base into height. And this is base into height. So, well, really it's height into base. And then it's going to be 1.25, which is B. Alrighty, an object is released from the stationary hot air balloon at height h above the ground. So it's going to go down. An identical object is released at height h above the ground from another hot balloon that is rising at constant speed. Air resistance is negligible, but is not increased for the object released from the rising balloon. Alright, so it's going to be its acceleration. And the reason for that is because if it has like a predetermined like upwards force from the rising balloon, then it's gonna take a longer time to reach the ground because it's fighting through this force, the upward force, and then it's gonna take the speed is going to be the distance increases because if there's an upward force, the ball's probably going to first go up and then go down, which increases the distance that it takes. And then, however, the acceleration, both the gravity is still the same for both of them. And also, although it takes more time and it covers more distance, and since there's increase in distance, there's going to be an increase in the final speed because there's covering more distance allows the ball to get greater time to reach terminal velocity. Yeah. So it's D. Its acceleration doesn't change. For this question, the car is moving a different, like, the dots are like becoming further and further away, as you can notice. But that means that there's a constant acceleration because the velocity is increasing at a constant rate. So, if the acceleration increased, then that would still mean that velocity is increasing, but it would increase much faster. As it's increasing at like a regularly like larger rate, like this is small, and then this is slightly bigger, and then this is slightly bigger, and then this is slightly bigger. Like that shows a constant acceleration, not an acceleration that's increasing. So it can be A or B, and it can be constant speed, because if it was constant speed, then it would be the same distance. It would be the same. But that's not true. So that's why it's D. Alright, a ball is tossed vertically upward with a speed of 5 meters per second. After how many seconds will the ball return until its original position? Well, when it falls down. Well, so from this question, although we're given only one quantity, we're actually given many. We can assume many. Acceleration is gravity, which is 9.81. U is 0 because it's from rest. The initial velocity, nope, it's 5. And we want to find the displacement is 0 because it's going back to its original position. And we want to find for the time. So what equation are we going to use? We're going to use the Syllabus equation of S equals ut plus half at squared. We plug in our numbers. It's going to be 0 equals to 5t plus half 9.81 and then t squared. And then it's simple algebra. It's going to be a quadratic equation. We're going to get 5t minus 4.905t squared. And then we can factor the t out from both of them. So we're going to get t5 minus 4.905. We equate this to 0. We're going to get t is around 1.02 seconds, which means it's going to be B. And if we like go to the number of significant figures, it's going to be around 1 second. That's why it's B. So the next question asks, a projectile is fired off the top of a cliff, so there's a certain height here, and then it hits the ground 4 seconds later, at a distance of 2 kilometers. Alrighty, and from the base of the cliff, what is the height of the cliff? Okay, so alright, the formula for projectile finding the height or displacement is going to be h equals to half gt squared. Now we already know all the values, so it's going to be half 9.81 t squared, which is 16, and that's going to give us around 78.8. Oh, 78.5, which is around 80 meters, and that's going to be B. Next question. Just know that like a lot of these questions from the old syllabus didn't really allow calculators, so that's why the numbers are really easy. But in the new syllabus, we allowed calculators for every paper, 1 and 2. So I'm going to be using the specific numbers. Alrighty. An object is released from rest in the gravitational field of Earth. Fancy way of saying just falling, okay. Air resistance is negligible. How far does the object move during the 4th second of its motion? Alright, it's been falling for 4 seconds. What's the distance? So, we are given, again, we're going to use the same formula, which is half, displacement is half gt squared. This is the free fall equation. So, it's so we're going to be given also in the question we can see that it says how much does it move in the 4th second of its motion. That doesn't mean that we calculate until the 4th second, because that would be too big of a number. What we're actually doing is subtracting the distance from the 4th second, where it currently is, and then subtracting it from the 3rd second. So we'll get like the total distance that it moved within the second of 3 to 4. So if you plug in the numbers, you're going to get 80 and 45. Subtract 80 minus 45, and you'll get 35, which is C. Alright, the next question is, a boy runs on a straight horizontal track. The graph shows how speed varies with time. Okay, that means he's accelerating, and then he runs at a constant speed. Alright. After 15 seconds, the boy has run 50 meters. What is his instantaneous speed and his average speed at t15? Alright, so in the graph we can see the boy runs along a horizontal track. Looks like this. This is 15. Then we'll notice that this is 5. That's why the instantaneous speed is 5. So A and B are wrong. And then the average speed, well, the average speed is going, at t15 distance was 50 meters, so we're going to do distance over time 3.3, well, around that. That's why it's a C. So 2 balls X and Y, the same diameter, are fired horizontally with the same initial momentum from the same height above the ground. Well, okay, so there's two of them from the same height. The mass of X is greater than the mass of Y. Air resistance is negligible. Alright, so one thing that's important is that the time to reach the ground, no matter the mass, is going to be the same if air resistance is negligible and they're the same shape and size. However, the horizontal distances are going to be different. So, since X is heavier, that means that it has more inertia. It's going to take more force to get it to move as fast as Y. That's why the horizontal distance is going to be less for X. Then how can it end up at the ground at the same time? That's because of the have a lot higher inertia for X. Higher inertia, what that means is that although it takes more force to get to a high velocity, at the end it's going to move faster than Y, so it's going to reach the ground at the same time. So that's why the answer is C. The truck has an initial speed of 20 meters. It decelerates. Okay, so the truck, the initial speed is 20. And then it decelerates at 4 deceleration. What is the distance taken by the truck to stop? This is another SULAT question. We are given the initial 20, the acceleration -4, the distance we gotta find. So what we're going to be using is v squared equals to u squared plus 2as. We plug in our numbers, and oh yeah, and also v is 0 because it's going to rest. So 0 equals to 20 squared plus 2 into -4, and then we have to find what s is. Simple algebra, you isolate s, you'll get as equals to 400. S is around 50 meters. So that's C. Alright, next question. The projectile is fired at an angle to the horizontal, the air resistance is negligible, the path of the projectile is shown. Alright, what you're going to find is the magnitude of the horizontal component and the magnitude of the vertical component of the velocity moment p. Okay, so this is a very simple. The horizontal component will always be constant with no air resistance, and the magnitude of the vertical component between O and P, it's going to increase. So the reason for that is because this is a basic projectile, and we're only analyzing from here to here. First, there's no velocity here. It's the horizontal component always going to be constant, no air resistance, nothing stopping it, so it's going to stay constant. However, the ball is going down. The object is going down. That means the velocity must be increasing, and if you break the projectile into its components, you'll get that at first there's nothing there, then it's going to increase a little bit, and then it's going to increase a little bit, and then it keeps increasing. The magnitude increases. However, the direction is negative, so it's going to be A. Next is a runner starts from rest and accelerates at a constant rate throughout the race, which graph shows the variation of speed of the runner with the distance traveled, S. Alright, so it's going to be A, and here's why. The thing is, these graphs are kind of like a Russian doll where each of them affects the others. So it's going to be this displacement and time is going, if it's like this, then that means that the velocity in time is going to be like this. That means that the acceleration over time is going to be like this. Sorry, like this. However, what if instead we consider that the acceleration is curved like that? What's the velocity going to look like? Well, sorry, what if it looks like this? Because it's increasing at a constant rate, so it's linear. It's okay, it's going to be definitely curved, but is it like this or is it like this? How do we know? Well, we can mathematically do it with algebra. If we use the kinematics, v squared equals to u squared plus 2as, and then we isolate v squared, we're going to get 2as, and the because the initial is 0, then we're going to get v equals to root 2as. That means it's going to be in the root form. If any of you guys know the root function, it looks like that. So it's going to be A. That's it. Alright. And then a skydiver is falling at a terminal speed and she opens her parachute. That means the drag force is equivalent to the gravity force. What the direction of her velocity vector and the direction of acceleration vector before she reaches the new terminal speed? Alright, so however, we're looking at the object right before it's reaching terminal velocity. So she's going to have different situation. So the direction of the velocity is going to be downward because she hasn't stopped moving. She's going to, there's still a resultant force that's going downward. So her velocity vector is going to be downward. That means A and B can't work. So there's the acceleration vector. Oh no, I made a mistake. Sorry, I flipped it. The magnitude. When she opens up her parachute, the drag force is going to be greater than the force of gravity, so she's going to move up a little. That's why her acceleration is going to be up. So it's going to be C. So what this means for her is that although she's falling down, she's actually falling down at a slower and slower rate because her drag force is counteracting her downwards velocity. Which is how you reach terminal speed. Okay, so a stone is thrown downward from the edge of a cliff, alright. With a speed of 5 meters per second, it hits the ground 2 seconds later. Alright, what is the height of the cliff? Alright, what we're going to do here is the free fall formula. So, oh wait, except it's not that because there's it has an initial velocity, so we're going to use the Subat equation of S equals to ut plus half at, and A is just gravity. So we're going to plug it in. That means U is 5 into 2 plus, well, I'll just put 5 as if we assume gravity is 10. 4, 20, so it's going to be 10 plus 20 is 30, which is B. So the next question says, a ball is thrown upwards at an angle to the horizontal. Air resistance is negligible. So a ball is thrown upwards at an angle to the horizontal. Air resistance is, alright, so it's not 90 degrees, it's at an angle. Air resistance is negligible. What is the statement about the motion of the ball is correct? The first option is that the acceleration of the ball changes. No, it doesn't. The velocity of the ball changes during its flight. So yeah, it does, because at first it goes up and then it decreases and then it goes down, increasing in magnitude. So yeah, since velocity is a vector, the direction is changing and so does the magnitude change. Say the acceleration of the ball is 0 at the highest point. No, that's not true. It's always gravity. It stays like the acceleration is always gravity downward, even at the top. And the velocity of the ball is 0 at the highest point. Well, no. Only the vertical component remains 0. The horizontal component of the velocity at the top still remains. That's why the velocity of the ball isn't 0. That's the correct answer is B. A large stone is dropped from a tall building. Okay. What is correct at the speed after 1 second? Well, two things are important here. One, it's a large stone. That means air resistance is not negligible. And two, it's a tall building. So there's a lot of time for the air resistance to act on it. So what the question is wanting us to infer is that air resistance is not negligible. Therefore, it's increasing at a decreasing rate. That means that it's going down and the magnitude is increasing, but it's increasing less and less because the air resistance is fighting back and increases. Air resistance increases as well. So it's D. Okay, and then the next question is, the graph shows how the position of an object varies with time in the interval 0 to 3. At what point does the instantaneous speed of the object equals to its average speed over the interval from 0 to 3? Alright, so for this question, it's a bit confusing, but how it works is that this is the curve. There's a there's B, and then there's C. Why C works is because it covers around 2 meters in 2 seconds, while B only covers this much. So C is the correct answer. Also, if you make a tangent, it's gonna look like this. And then if you make it for B, it's gonna be like this, which is too low. And for A, it's even lower. So you gotta pick one that matches closely to y equals to x. Or aka, the slope has to be 1. So the next question is, the graph shows the variation of the velocity of the body with time along a straight line. The maximum acceleration is at p. Or, well, this is something that is remembered through content. In your textbook, you'll probably see that it's only in the velocity time graphs where the area means the displacement. It's only in an acceleration time graph that it actually shows the speed change with a velocity change. That's why it's D. Alright, P and Q leave the same pole and traveling in the same direction. The graph shows the variation with time t of velocity v for both P and Q. So for this question, we're going to first realize that it's a velocity time graph. What that means is that under the area, it actually shows us the distance or displacement. Nope, that's a bad way to represent that. Or displacement. So what are we going to do? We're going to find... So at 8 over here, at 8 over here, we're going to find the entire triangle area for Q, and then we're going to find this this triangle for P, and there's this rectangle for P, and then we're going to subtract them to find the distance between them. So let's do that. For P, it's going to be the triangle and the rectangle. So it's going to be 3 base into height 20 divided by 2 plus 8 minus 3, which is 5, into 20, which will give us 120. And then for Q, it's just linear, so it's going to be 8 into 40 over 2, which is 160. And then if we subtract 160 minus 120, it gives us 40, which is B. And that is the correct answer. Alright. By the way, I checked my answers, so don't worry, every single one of them is right. I'm not just like BSing. It's from the mark scheme. Oops, spoilers. Anyway, for this question, a balloon rises at a steady velocity of 10 meters per second. An object is dropped from the balloon at a height of 4 meters above the ground. So a little object, okay, 4 meters above the ground, 40 meters. Air resistance is negligible. What is the time taken for the object to hit the ground? So you're going to have to take the velocity as negative. It's because it's going to fall down, and this is what we're looking for. So we're going to take the opposite as negative because it's going against what we want. And then it's gravity, obviously 9.81. And we gotta find the time. So we're going to use the Suvat equation of this, and we're also given this displacement, which is 40 meters. So we just plug in our numbers. It's going to be negative times, we'll just leave it like that, plus, actually I'll write it in clearer, 10 plus half, and just let's take it to 5t squared. It's going to be a quadratic. And so I've solved it. I've used the x method to factor the quadratic. I'm sure all of you already know this. And then t time can only be positive. Time can never be negative. So this is an invalid answer, and it is C, which is true. Alright, so the next question. The horizontal force acts on a sphere, okay? And a horizontal resistive force is a... Alright, I'll just do that, I guess. And a horizontal resistive force kV acts on the sphere, where V is a speed and K is a constant. Okay, what is the terminal velocity of this sphere? One thing you gotta realize is if you want to find the terminal velocity as it's given in the question, we gotta equate them. So it's F is equal to kV squared. So it's then we isolate V. So it's gonna be that's it, which is D. Alright. An object is pushed from rest by a constant net force of 100 newtons. When the object has traveled 2 meters, now let's make it 2 meters, the object has reached a velocity of 10 meters per second. What is the mass of the object? Well, we are given the force, the displacement, the velocity, final velocity, and we want to find the mass. So we are going to need to find clearly the acceleration first, because as we all know, Newton's second law, F equals ma, and we want to find out the mass. But since we're given the force, that means we got to find this, and then we can use these two to find the mass. Alrighty then. I'll just keep it there actually. What two-bit equation do we use? We're going to use the, oh yeah, also u is 0. So we're going to use the S equals to u plus v. Nope, we're not using that. What? We're going to use the one without time. So it's going to be v squared equals u squared plus 2as, which is going to be 10. 10 squared is 100. Is 0, so we just don't do that. 2, and acceleration is what we're trying to find for. And we're given s, which is 2 meters. So we're going to get 4a, which means a is 25. That means 25 meters per second squared. You don't need units. I don't really care about units. And then we're going to use it to plug in here. So we're going to get 100 newtons equals to mass into 25, which means the mass is 4 kg. Oop, what am I writing? 4 kg, which is ta-da. Alrighty, next question. So the next question asks for the graph of the shows the variation of time t with the velocity of the object. Velocity, time, 0. Looks like that. Funky. What is the variation of time t and the acceleration of the object? Well, now if you convert it to the acceleration version, what we're gonna be doing is that we can see that it's gonna go, that the velocity is, it's increasing, but then it starts to decelerate, where it's decreasing, and it's going, and which means that this entire section where it's decreasing, it must be negative. So, and it's gonna look like that, which is A. Alrighty. Sorry for my lisp, I'm getting really tired. Alright, then the next question is, a ball is thrown vertically downwards with an initial speed of 4. Alright, so it's going to be like that. 4 meters a second. And the ball hits the ground with a speed of, well, alrighty. Just before getting to 0, air resistance is negligible. What is the time of fall? Alrighty. So, what we are going to do here is, we are given U, V, and A, which is obviously gravity because air resistance is negligible, and we want to find the S, which is clearly v squared plus u squared again. Man, they really do like using this equation. All the other equations probably feel lonely. So, final is 16 squared equals to 4 squared plus 2 into 10 s. So it's going to give us... Alright, I went ahead and solved it for you. It's going to give us 12, which means that it can't be A and it can't be C. So what is it? Is it B or is it D? Well, the time of fall, we can find that by S equals to U plus V over 2T. And we all know it, so it's going to be U is 4 plus 16, 20, 20 and over 2 is going to be 10T, which means T is 1.2. Which means it's going to be C. It's going to be D. What the hell? I just said it can be C. It's going to be D. Sorry. And then, next question. Okay. The road from city X to Y is 800 kilometers. Alright. And the displacement... Well, nope, that's the displacement 800, but the road is 1,000 because the city officials don't know what they're doing. Just kidding. And distance traveled. What is the distance traveled from Y to X and the displacement from Y to X? Well, this might be one of the easiest questions of all time. It's going to be, the distance is obviously going to be 1,000 because this is the road. You can't really fly over there if there isn't a road. So it can't be A or C. And so it's also negative because we got, if we're taking X to Y as positive, that means going back it has to be negative. Because displacement is a vector quantity. So it's going to be D. Sorry. A car accelerates uniformly from the rest to velocity v during time t1. Oh my god. No numbers. And... from rest to velocity v during t1. It then continues at a constant velocity from t1 to t2. Alright? And then continues at a constant velocity. Alright, so it's gonna look more like this. What is the total distance covered by the car in t2? So, what we're gonna do here is we gotta realize that it's you gotta find the distance traveled here, and then add them up together. How do we do that? Well, it's increasing at a linear rate. That means we gotta do initial. To find the average speed, we gotta do initial plus final over 2 into t. But our initial is 0 because it starts from rest, so it's just gonna be v over 2 into t1. We add this to the constant section, which is going to be v into t2 minus t1 because we don't want to include the section before t2 minus t1, and we'll realize that that actually matches d. So let's try to simplify to match d completely. Okay, turns out that this could be a formatting error because this question literally has to have the brackets in it because you can't subtract different units. So, oh well. Anyway, next question then. An object is sliding from rest at an inflectionless inclined plane. The object slides 1 meter. Okay, so it's sliding at 1 meter as shown in the diagram. What distance will the object slide during the next second? So since it's frictionless, the gravity is gonna be like this, and then there's the x and y component. However, as it's frictionless, the horizontal component doesn't really do any work here. So we're only going to look at the vertical component, and that can be analyzed with the free fall equation, which is s is equal to half at squared. So if we plug in after 2 seconds, then it's going to be s2 is half a, we'll just put 5 t4, 2 is because 2 to the power of 2 is 4, so we're going to put 4 is 20. Oh wait, I made an error. It's not gravity actually at all. So it undergoes a constant acceleration, but it's less than gravity. So okay, we can find out what the acceleration here is. This just becomes half a. That means a is 2 meters per second. We can continue to use the same equation over here, except for 2. So it's going to go as half 2, 4, 8, 4. That means s is going to be 4, because this cancels out to become 2, and then becomes 4 meters. And we already know that from the first second it covered 1 meter, so we subtract them. 4 minus 1 is 3. That's why the answer is C. Alright, next question. The minute hand of a clock is hanging on a vertical wall that has length 30 centimeters. The minute hand is observed pointing at 12, then again at 30 minutes later, and the minute hand is pointing at 6. What is the average velocity and average speed of point P on the minute hand during this time interval? So what are we given here? We are given that the minute hand has a clock has a length of 30 centimeters, and that it starts at 12 and then it goes to 6 points down. We need to find the average velocity and the average speed of point P, which is the tip of the minute hand during this 30-minute interval. So how do we do that? Well, the definition of average velocity is that it's the total distance, change in distance over change in time. So it's gonna be that it took, let's say, if one length is 30, then you multiply it by 2 to get 60 centimeters. And over 30 minutes, which gives us 2 centimeters a minute. Well, I guess I'll just... So, vertically downwards. And to find speed, it's going to be distance over time. So the distance is going to be the radius into the radians. So we're going to get L into pi, which is 30 pi, and since that's the distance over 30 minutes, we're going to get it's moving at pi centimeters per minute, which corresponds to option number A. Also, just to make it clear, the reason we're multiplying it by 2 is at the top over here. It's if you mark this the origin, it's around 30 centimeters away. But then the moment it goes like that, it's going to reach over here. and it's going to be 30 plus 30 centimeters, aka 60 centimeters in total away. So that's why. Alright, so a block is moving with an initial speed v, is brought to rest. So v, so u is v, and then v is 0. Alright then, I guess. And after traveling a distance d, s is d, by some frictional force F, then a second identical block moving with initial speed u is brought to rest in the same distance d by a frictional force of F over 2. What is u? Alright, so what we're going to do here is... Okay, so for this question, it's a bit different because this is already delving into topics that are from A2, work, energy... Nope, that's momentum plus. From A3, work, energy, and work and energy. So I'm going to use it through energy principles because that's just the easiest way. Work is change in energy, kinetic energy specifically. So the formula for kinetic energy is half mv squared. So what we're going to do is we're going to equate block 1's kinetic energy with block 2's kinetic energy, and then see what, we'll not equate them, but just see what's possible. So for block 1, it's well, it's going to be the work done. By the way, the formula is FD. So the and work is change in kinetic energy. So what we're going to do here is multiply to find a work, and then half mv squared, and do the same for the second block, which is F over 2 into d is half mv squared. Okay, so how do we isolate u? Well, oh, so it's u here, not v. How do we isolate u? Well, what we're going to do is we are going to divide the equation so we can get rid of the d's and the m's. So it's going to be f over 2 into d over f into d equals to half mv squared, mu squared over half mv squared. M's cancel out, halves cancel out, d's cancel out, and this u squared over v squared, and we're simplifying it, and then we will get that u squared is half of v squared, which means that u squared is v over 2. So this matches with option number B. A stone is kicked horizontally at a speed of 1.5 meters from the edge of a cliff. Alright then. It hits the ground 2 seconds later. 4 meters is the height, air resistance is negligible, which means gravity is 10. What is the magnitude of the displacement of the stone? Basically, what is the distance here? So, it's a very easy question. Equals to half the free fall formula, 10 into, it's 4, because 2 squared is 4, and that's going to be 5 into 4, which is 20, well, not really. That certainly isn't the method. I didn't account for the initial velocity. So how we're going to solve this question is through, since we're not really like, we can break this into the horizontal and vertical components. So it's 1.5, and this is 4 meters, but that's this velocity. How do we convert this to a distance then? Well, it's 2 seconds. 1.5 into 2 is 3. So this is 3 meters, and we gotta find this. Well, that sounds like something for Pythagoras' a squared plus b squared. Well, not really. This is just this formula where it's x squared plus y squared equals to the displacement. So it's gonna give us 9 because, well, 3 squared is 9. So plus 16 because 4 squared is that, and it's gonna give us 25, which is 5 meters. That means that the displacement is 5 meters, aka b. Alright, is this the last question? Second to last question. Final push. A cart travels from rest along a horizontal surface with constant acceleration. What is the variation of kinetic energy of the cart with its distance s traveled? Air resistance is negligible. Alright, so it's the kinetic energy, and this is the displacement. It's starting from rest, so that means it can be c, with a constant acceleration, which means it can't be b or a, because it's curves, which means it's changing, but the acceleration is constant. So it has to be d. Alrighty then. The variation with time t of the acceleration of a of an object is shown. Okay. What is the change in velocity of the object from t0 to t6? So for this question, we're going to find the change in velocity for an acceleration versus time graph. We're going to realize that the area is the change in velocity, so we have to find what is the area of all the shaded region. There's an easy way to do this, which is first we're going to find the area of this triangle, which is 6 base times height, basically. So 6 into 3 is 18, and then divided by 2, which is 9. But we also need this, and we can find the other triangle by multiplying 2 into 1, which will get us 2, and then dividing it by 2 to find this triangle from the square, and then we'll get 10, which is C, and is also the answer. And that's it. That is the entire question bank for the old syllabus, 2.1 motion. Alright, from Pestle, it's over. Oh, let's go. Let's write it down. Alright. Next up, I'll be doing all of the HL only content, which is not much at all. Bye-bye.